So, amines multiple choice questions. Methylamine reacts with bromoethane by nucleophilic substitution to produce a mixture of products, which is not a possible product of this reaction. A and B. Methylamine reacts with bromoethane, nucleophilic substitution, which is swapping out. Definitely A and B are definitely possible products. Therefore, that is not the answer because the question saying which is not a possible product of this reaction. Left with C and D. If I look at C, C2H52NCH32, and then you got your positive charge Br minus C2H53NCH3. Yeah, that C is wrong. You won't get C2H52NCH32, no. Therefore, C is not a possible product of this reaction. Question 2. Methylamine reacts with, is that just not the same one? I repeat question C. What is it that is it the exact same? No, it is slightly different. Okay, so again, A and B definitely are products, definitely are possible products. I'm left with C and D. In this case, because if I look here, the reason C was not possible products, where did I get that CH32 from? 2 methyl groups. It's definitely not possible product. And if I look in here, where did I get that CH32 from? 2 methyl groups. Therefore, the answer is D, where C, that's completely correct when you got 1. So just look for that small detail. And then question 3, aqueous solutions of ammonia, ethyl amine, and phenylamine are prepared. Each solution has the same concentration. Okay, which is the correct order for the pH values of these solutions? Ammonia, ethyl amine, phenylamine. Correct order for the pH values. No, ammonia would be, ethyl amine would be greater than ammonia. That is for sure. Because ammonia, think about it, ammonia, NH3 with the lone pair of electrons, no inductive effect, therefore it's definitely not gonna be a stronger base. The answer A is wrong. B, again, phenylamine is greater than ammonia. C, ethylamine, which is greater than ammonia. No, sorry, phenylamine is not greater than ammonia, and then ammonia is greater than phenylamine. Phenylamine. Now, if we look at phenylamine, we've got the amine, we've got the phenyl group, and directly here you've got your amine. And because it's in the direct line of sight, this phenyl group adds it to stability. Therefore, it's going to have the lowest pH value in this case. And ethylamine is greater than ammonia, and therefore ammonia will be greater than phenylamine, and therefore the answer is C. And if I look at D, no, D is wrong, obviously. Question 4, which compound is the strongest base? Ammonia. Well, if I look at ammonia, NH3 with the lone pair of electrons. Now, it might look like that can donate a lone pair of electrons or accept it, right? So therefore it's going to be a stronger base, right? But it's got no inductive effect, and therefore it's not going to be a strong base. No inductive effect. No inductive effect. So I can cross out ammonia. Ammonium chloride. Well, what is ammonium chloride? Well, I've got ammonium ion, NH4+. Obviously, it's an ion. Plus, and I've obviously got my Cl- on the outside of it. this plus for the NH4. Well, there's no lone pairs of electrons to donate. Therefore, it's not going to be a base. So if it doesn't have a lone pair, it can't be a lone pair donor, and therefore it's not going to act as a base. No lone pair of electrons, therefore can't act as a base. So it's definitely not going to be ammonium chloride. And now I'm left with methylamine, phenylamine. Now if we draw these out, methylamine, I've got my amine, lone pair of electrons, CH3, phenylamine, I've got my amine, lone pair of electrons, a phenyl group. But because the phenyl group, the phenyl group is directly, the amine group is directly neighboring the benzene ring, and that's the delocalized electron benzene ring. And we should know about benzene ring. It's very stable. Benzene is very stable. That's why we also need with that electrophile mechanism to attack it. It's very stable. Benzene ring, very stable. Therefore, you might think, therefore it's going to be the strongest base. No, because then it's going to be less likely to donate lone pair of electrons. Therefore it can't be D, therefore it must be C. And if you look at C, the methylamine that I've drawn, it's got that positive inductive effect of the alkyl group. Therefore it will be methylamine. It's got that inductive effect. And then question 5, what type of reaction is used to convert CH33N into the cationic surfactant this? Bronsted-Lowry acid-base reaction. Bronsted-Lowry. That is in acids and bases. Topic. It's definitely not that. I feel like I just added that one. And they knew probably most students would cross it off. They're definitely not that. And now I'm left with quite nucleophilic addition elimination, nucleophilic substitution, all the nucleophilics. And it's obviously from year 1, that's from year 2, that's from year 2. Yes, and then A-level content. So the answer, but with the nucleophilic addition and the nucleophilic addition elimination, it's not going to be either of those, because if you look here, we've got CH3N, and we've just substituted something on it. The answer is going to be nucleophilic substitution. And that is the end of the amines multiple choice questions.